And let's have a quick talk about systematic sampling. This is a bit different again. To do systematic sampling, we require a list of every member of the population effectively. We need to know every single member of the population. We're then going to randomly choose the first member to be included in the population. So let's say we had 100 things in our population. We could randomly choose the fifth member to be the first person or the first thing to be included in our sample. After that, we choose a fixed interval. So we might pick every third member after that. So in this case, we'd line up our 100 people in our population, and we'd pick the fifth person, then the eighth person, then the 11th person. So we could, if we imagine this is our population listed out. So obviously I'm not going to go all the way up to 100, but you can see where I'm going with this. It's going to carry on. And then we pick out, we could say we're going to pick out the fifth member, and then every third member after that. So you can see we're just going to pick out every third member. In theory, this should be random. In practice, it can be hard to achieve this. There are ways in which this can become not random. It's a little bit of a complicated scenario to think about. But for instance, say we randomly pick houses, and we pick every third house to be sampled. Maybe on the street we're sampling from, every third house is a detached house instead of a semi-detached house or something like that. We can introduce bias by that, and our survey results might say all the houses are detached, but actually it's just because of the way we sampled it. So we have to be careful we don't introduce bias. Really, we need to make sure our list itself is unbiased. And a further problem is that often we can't get a list of every member of the population. As I've mentioned before, sometimes we just don't have that available. If we're talking about sampling insects again, we just don't have a list of every single member of the population. It's just not something we have. For people, it's often less of a problem. We do often have lists of people, so we can see, we can try and be random in the way we do a survey. But that's often not possible to do. Now, when we are trying to take our systematic sample, when we choose our fixed interval, so that's the bit where we said we pick every third member or fifth member or 10th member or whatever it is, we've probably got a sample size in mind. So we've got the population size, which is the whole population. So in my example before, there was 100 people in the population. And our sample size is how many people we want to actually have in our sample. So we might say we want 5 people in our sample. We just want a very, very small sample of 5 people. If we know our population size and sample size, we can work out how big our interval needs to be. And to work out the size of that fixed interval, we use this formula here. So in my example we just had before, to work it out, we'd say we've got a population of 100 people. We want a sample of 5. That gives us 20. So that means our fixed interval needs to be 20. So we're going to pick every 20th person. So if we started with the 5th person, we'd pick the 5th, then the 25th, then the 45th, the 65th, and the 85th. And you can see the next person will be the 105th, which is off the end of the population. We're past that 100 mark. And as you can see, we have a sample of 5 people. Okay, so you can see using that formula, make sure that our sample is the size we want it to be. So we'd probably come up with a sample size beforehand. We decide how many people we actually want to collect information from. We need an idea of how big our population is. And from that, we can come up with our fixed interval.